Hi everyone. In this video, we'll study how can we use interrupts in 8051 microcontroller. Interrupt is a very interesting feature that a microcontroller has, and it makes the life of a programmer much easier if you understand interrupts. However, I know that if you are a student or if you have recently studied microcontrollers, then interrupt looks like something very difficult from a distance, but actually it isn't. So we are going to study the interrupts of 8051 in this video, as well as we will try to see an experiment, or we will see a demonstration of how we can use external interrupt on 8051. So let's get started. Now, whenever you have to understand the concept of interrupt, I give a very simple example. Okay, let's assume that we are sitting in a classroom environment and I'm teaching a particular subject, and let's say there are 50 students sitting in front of me. Now, while I'm studying or while I'm teaching that particular topic, some important message may come from outside. I don't know, maybe some message from principal's office or something. Hypothetically, let's assume that there comes a message on my door, classroom door. Now, at this time, the teacher or me, I have two choices. One choice is I'll keep doing what I'm doing. I'll keep teaching the topic that I'm teaching about, and then I'll let that person who is bringing the message wait on the door for some time. Now, this is the choice I have. But the second choice I have is I'll stop you, or I'll stop what I'm teaching. I'll immediately go to that person. I'll do whatever he wants me to do or sign whatever piece of paper he wants me to sign. And then I'll get back and I'll start from the exact point where I had stopped. Now imagine if I do that with a speed of a superhero flash. So in that case, what will happen? You will not even understand. The students will not even understand that I stop teaching and then I get back, because it will happen in a fraction of a moment or something like that. Now, this concept, when you apply to microcontrollers, it's called as polling and interrupt. Polling means I am letting that person wait there. I will finish my execution and then I will attend to that person. Interrupt means I will stop my execution, I will stop my teaching, I'll immediately get back to that person, do whatever business is to be done, and then get back and continue with the teaching. Now, if you are creating an embedded system where you have used an emergency switch, okay, and let's say if you have built a crane, when you press a button, the crane is supposed to move for 10 seconds. I repeat, when you press a button, the crane is supposed to move 10 seconds. Now, if this is the situation, and if I have an interrupt or if I have a emergency stop button, there is no alternative. I don't want those 10 seconds to be finished and then get back to stopping the train. Another example, if I am creating a temperature controller where after every 10 seconds or after every 30 seconds, I will check if the temperature has risen above a particular level, and then I'll start the cooling system. Now 30-second gap is okay for cooling system. It's completely fine. Even if I wait for 30 seconds and then check the temperature and then turn the cooling system on and off. Every 30 seconds means I'm checking it twice a minute. It is okay. I can do cooling here. But if I'm operating a crane, if my program is written for 30 seconds of crane movement, and if I press the emergency stop button and if it doesn't stop immediately, that's a big hazard. So in order to deal with such real life scenarios when building systems, we have to use interrupt. Some piece of code should be executed immediately when an external signal comes or when a particular activity happens. And even my regular code or whatever my execution was going on, that should also keep going on. Sometimes it may happen that the input is coming from a sensor which is just incrementing the count and doing a lot more different processing. It may not be that emergency a situation, but you still want to address it because you don't want to interrupt your regular execution. So these are some of the examples where you can use interrupt. I hope the concept is explained to you. Now let me tell you from the programming perspective how it works. So whenever a microcontroller is executing a particular piece of code, it has a register called program counter, which is loaded with the next instruction to be executed. That next instruction address is the address of flash memory, where the particular program is saved. Now what happens is, whenever an interrupt occurs in a microcontroller, the program counter, which is loaded with the next instruction to be executed, is removed and it is loaded with the address of that particular interrupt, as you can see on the screen. Now what the program counter does is then it loads it with this address, so microcontroller will go on to that particular address, execute whatever is written there, and then come back and loads the original address where the execution was stopped, so that it keeps going on. Now imagine I'm blinking an LED with a delay of 1 second, and if the microcontroller is halted for several microseconds so that it goes to a place, executes something, comes back. My regular delay blinking routine, I will not even notice there is a change. But at the same time, you have achieved something of a multitasking using this interrupt. So this is how it works in microcontrollers. Now, 8051 has primarily 5 interrupts, but I would still say 6 because there is one more interrupt called reset, which is a non-maskable interrupt. Whenever you give a reset signal, everything is flushed and your program counter will be loaded with 0000H. Now, there are 5 other interrupts which are external interrupt 0, timer interrupt 0, external interrupt 1, timer interrupt 1 and serial port. You can use external interrupt when you want to trigger an interrupt based on external signal, maybe a high signal, maybe a low signal. And there are 2 external interrupt inputs we have, which are merged with port 3.2 and port 3.3. Then we have 2 timer interrupts. These timer interrupts can be configured to be used whenever the timer overflows. So we have 2 timers, timer 0 and timer 1. Therefore, we have 2 timer interrupts. And then there is one serial port interrupt. This serial port interrupt can be configured to use whenever you receive some data on the RxD pin or whenever transmission through a TXD pin is completed. So in this video, for the scope of this video, we will try to study how we can use external interrupt 0, how we can use an external interrupt with 8051. Let's continue further. Now, if you have to use the interrupts, just like any other thing in microcontroller, the interrupts is also configured using special function registers or SFRs. There are two SFRs that you will primarily be using. One is called as interrupt enable register and second it's called as TCON. Now I know TCON stands for timer control, but yes, because the bits are redundant, it is used for interrupt enablement as well. Let's first of all see the interrupt enable register. Now if you look at this register and if you see the bit number 7 first, it's a global interrupt enable disable mask. The bit is important because if you make it 0, it doesn't matter even if you have individually enabled other interrupts or not, everything will still be disabled. Consider this as a larger gate beyond which there are individual gates. So it doesn't matter if the individual gates are open or closed. If the larger gate is closed, nothing can pass through. EA bit acts like that. Why it is done? Because in many cases, you want to disable all the interrupts in one go, one instruction. That can happen if you make the EA bit 0. If you make EA bit 1, it means you have enabled the global gate. Now, you can go on and enable individual interrupts as per your choice. They will function. But, okay, I think that's it. Let's continue further. D6, D5 are redundant. D4, D3, D2, D1, D0 are the 5 interrupt bits for enabling or disabling 5 different interrupts. As said, I am interested for now in external interrupt 0. So if I have to test external interrupt 0, I will make this bit 1, I will make this bit 1. You can write that as a register 1000 0001, that will be 81H, or you can individually set EA is equal to 1 and EX0 is equal to 1. Both of them will do. Now this has enabled the interrupt. Now how you want that interrupt to function is decided using this TCON register. Now as you can see, there is TR1, TF0, TR0, IE1, IT1, IE0, IT0. Now for all these bits, I am currently interested in IT0 bit because if I set it, my interrupt will be triggered as a negative edge, IT0. Making 0 will enable the interrupt. So if you enable IT0, if you set IT0, if you make IT0 bit go 1, then a 0 coming on the external interrupt pin will enable or trigger the interrupt. Now similarly, you will see there is IT0, there is IT1, and then there is IE0 and IE1. So if you want level triggered, then you make this particular bit 1. 0 basically removes the trigger at all. So 0 doesn't have any function. So either you make IT01 or IE01. Now because the pin is by default high, I want to make it the interrupt appear when I make the pin low. So if you're not understanding it, just assume for now that you make IT0 bit high and see what happens next. After doing several iterations with these bits, you will get the gist of it. For now, I'm going to make IT0 bit 1 because I want my interrupt to appear when a 0 signal is given to the external interrupt pin. Remember, whenever we are speaking about external interrupt 0, IT0, here EX0, it is all about making the external interrupt 0 pin function as interrupt, which is P3.2. Now, my code will go like this if I have to enable external interrupt 0. So, EA bit 1, EX0 bit 1, IT0 bit 1. This will make the interrupt fire when you make INT0 pin go low. Now, that's it. What next is, how do you write this function? You have to remember one thing. Interrupt is not a routine which microcontroller will call in its regular program. It will be written as a separate function, but you will not call it. Why? Because it will be called upon directly, automatically, whenever that interrupt is fired. Keil has a peculiar way of writing interrupt functions. The way is very simple. You write a void, whatever name you want, void function, and then give interrupt number. So interrupt 0 here means, if you look at this list, external interrupt 0. Similarly, you can write any interrupt by adding that particular number over here. Now let's look at the example. Okay. For this example, what I'm going to do is I'm going to use the LCD interfacing code, and let's say for my regular execution, I'm printing the number of seconds on LCD. I don't want this routine to be stopped at all, but I still want to service my interrupts. What I've done here is I have connected a switch to P3.2, that is INT0. Switch is connected against ground. And then I have used an LED connected to P3.0. So what I'm going to do is I'm going to run this code in such a way, or I want to run this code in such a way that whatever function I have on LCD should keep going on. But whenever the interrupt is triggered or whenever an interrupt is fired, I want to toggle the state of LED. So if it is on, it will be made off. If it was off, it will be made on and onwards. Now for that sake, I'm using the regular LCD code. Let me just do one thing. Let me make the LED go 0 initially. So there is nothing in this code. The whole routine is for LCDs. I will show you what I have done for interrupt. So I have enabled this S-bit LED on pin 3.0 for toggling. Then you will see I have EA1, EX01, IT01. The 3 bits are made 1 to enable external interrupt 0. And then you will see there is a function written here, void ISR EX0 void. It should be void only because you don't pass anything to interrupt routine and you don't return anything from interrupt routine. Always. It always works like that. And then interrupt 0 because it is external interrupt 0. What we have written here is LED is equal to toggle LED. This symbol is basically the not get symbol or negation symbol. So if it was 1, it will be made 0. If it was 0, it will be made 1. And this function is not called anywhere. So if I read my void main, it is all about LED 0, then making the initial count 0, LCD initialize, then I'm printing welcome, then I'm clearing the LCD, then I'm enabling the interrupts, and then in my while one routine, it's nothing but I'm printing seconds. So on the first row, I have printed seconds, and on the second row I'm printing the count, and the count is incremented after every 1 second the code repeats. Simple as that. There is nothing. But assume that this is your heavy execution or whatever it may be. Whenever the interrupt comes, this function will be called upon automatically and your LEDs will be toggled. Now you can use or you can write multiple lines over here. The only thing that one has to take care of is never use delay routine in interrupt, because it defies the whole purpose. If you put delay routine here, then what's the use of interrupt? Just do your execution here in the fast and crisp manner and then exit from here. I hope the code is much simpler, and LCD we have already seen. If you have not understood LCD before or not seen before, it's very simple. I'm connecting RS to pin number 1.0, enable to 1.1, RW of the LCD is grounded, and the whole data line is connected to P2. I have different functions for printing text. I have one function for printing number as well. That's called LCD underscore print. Here I specify the row, column, the variable, and the number of digits I want to print. So if there is 35, it will be printed as 035. Or if I make it 4, then it will be printed as 0035. Now my code has been built. Now let me run this particular simulation. So you have seen all the connections are as expected. Now let me simply click on the run button. Now welcome. Then after a second it will be cleared. Number of seconds, 4 digit 0000. After every second that particular number will change. It will become 2, it will become 3, on and on. Now what I want to do in between of this execution is I want to stop my microcontroller or interrupt my microcontroller. You can also see my LED status is off. Now you'll see if I just press this button once, what happened? My LED immediately turned on. But do you see any change here in the execution? There is no change, because when the interrupt occurred, the program immediately went on to that location, immediately executed that pin toggle function and returned back. And it happens so fast at 11.0592 megahertz or whatever crystal frequency you are using, then you will not even experience it, you will not even observe it, that there was such a change happening. So this is how you will use external interrupt. If you don't understand things, please go through this application note that I'm giving along with this video, which is Keel's way of writing the interrupts, and re-listen or reread it once more. You can also go to microcontroller's datasheet and try to understand the SFRs in detail. I have covered things which are useful for quick practical experimentation. However, some people may need more detailing. So for those, I will definitely refer you to go through the datasheet of 8051 and understand the bit structure. Similarly, you can enable the external interrupt 2 and external interrupt 1. Currently, I am using external interrupt 0. That's it. All the resources is provided. Download the code, download the simulation, or perform it on your hardware and see for it yourself. Thank you for watching this video.